first introduced to linear equations, the very first question that we must address is, what is the slope of a line? Once you have an understanding of not only what it represents, but how to find it, it will be much easier to write and graph linear equations. So let's jump into it. When you take a look at the slope of a line, you are essentially understanding that it is a quantifying way to compute the slant of a line, if I can use that word. Often, we use the interpretation rate of change as a way to help you apply linear graphs and understand that over time, something is changing, and that rate, that speed, is slope. This is the foundation of moving on from algebra into calculus, and really important that you understand both those meanings for slope. M is often the variable used when presenting the formula for slope, which is the following: y2 minus y1 divided by x2 minus x1. Both of those represent the coordinates of 2 points. We then use rise over run to help you have a visual application of what these points are on your line. So here we are on our graph with our x and y axis. Remember again, this is your run and this is your rise. So both our horizontal and vertical distances are on the x and y axis. Let's take a look at a line. As I draw it from left to right, I need you to see on your screen that that line was rising. On the other hand, if I have a line coming downwards from left to right, that line is decreasing. You will also see lines that stay flat, and we call these horizontal lines. And lines that are perfectly straight up and down are our vertical lines. Now, you see 2 lines in front of you, a blue and an orange. Take a quick moment and think to yourself, which one is rising and decreasing? As you do that, I'm going to fill in the coordinates of the points that are shown to you on these lines. Just a quick reminder that your x coordinate always goes first and your y coordinate goes second. So when I stay flat on my x-axis, like the one on the far right, this 10, 0, my y-axis, my y value did not go up or down, so it stays at 0. And on the far left, -8, 2, I went to the left, so my x was negative. When computing the slope for the blue line, I'm going to begin with my 7 and subtract my -4. That simply meant that I wanted to use x1 and y1 and x2 and y2 as the coordinates, but it doesn't always have to be that way. It could be, you could have decided that you wanted to start with the -4 and subtract the 7. Since I started with the 7 as my y coordinates, I must start with my 3 and subtract my 0. When doing this, I'm going to get 11/3, and notice that it's no surprise that my slope of the blue line is a positive number because my line is increasing. On the other hand, if I wanted to calculate the slope of the orange line, again, when I start with the difference in the y values, it's up to you where you want to begin with. If I start with my 2 and I subtract the 0, notice that both of those are y coordinates on the orange line. I must begin with the -8 and subtract the 10. When I do so, I'm going to get 2 over -18, which reduces to a -1/9, and my slope is once again negative because my line is decreasing. Lastly, sometimes you're just going to be given 2 points and no picture will be given to you, and you will be asked to find the slope. So let's do it both ways just to prove that whether we do 8 minus 5 over -3 minus 1, you can also do 5 minus 8 and divide it over 1 minus -3. One of the common mistakes that students make when they are calculating slope is errors in integers. So go back and take a look at that video where we describe how to compute with positive and negative numbers. Take a look at our final answer. We're going to get a 3 over negative 4. And on the bottom one, we're going to get a negative 3 over 4. In both cases, we are getting the same slope. So there is your practical way of calculating slope. Let's finish up our video by just going over the form of two equations of a line that we will then get into in your next lesson. The first one is slope-intercept form, and both the words tell you exactly what lies in front of you. The m is the slope and the b is the y-intercept. In the second one, point-slope form is used because we're going to use the point x1, y1, and we're also going to use slope. Notice that in both cases, like I shared earlier, by convention, we tend to use the variable m, but it really could be any letter of your choosing. Notice that the position is in front of the x, in front of the parentheses. So finally, here are two examples. Take a moment to yourself and think to yourself, what is the slope of each line? If you wrote down or thought 1/2 and negative 3, you are correct. So in the first case, my line is definitely an increasing line because my slope was positive. In my second line, my slope is definitely decreasing because it's negative. So with that, we conclude our lesson for slope. Now we can move on to understanding how do we write the equation of a line and use them to graph. Thank you for listening.